Hello, guys. Welcome to the Record Genius Academy. So today we are here to discuss the next topic on Linux system programming. And earlier we have discussed the inter-process communication, where we have discussed different IPC mechanism. In this, like in which pipe, named pipe, message queues, and the shared memory we have discussed, and we have implemented the sample application to demonstrate like how they are working. And so today I just want to go further in Linux system programming. So what else we can do in Linux system programming? So I have just separated these things into some topics and all. So first we will discuss about the synchronization technique. So today we will discuss about that thing. So later on further programs, so we'll deep dive into signal handling, so how we can handle the signals and all. So later we can jump into the thread management, and we'll see the mutex locking and system, this another synchronization techniques. Then we'll go to the file management. What will be the hard link, what is soft link, how we can handle the inode structure and all these things. So we'll take care in file management, and later on we'll discuss about the memory management. So what will be the absolute code, what is relocatable code, how memory management will partition the RAM, what are fixed partition, dynamic partition. So there are so many things in memory management. So we'll discuss about that thing. And last but not least, there are so many syscalls. So we'll try to cover as much as we can. So there'll be a exec, there'll be dupe system call, there'll be fcntl for locking system. So there are multiple calls, so which in which, like in IT culture, most of the developers are using just to do their work and all. So we'll try to cover most of the things. So let's get started to for the first topic. So our first topic is synchronization technique. So today I just want to discuss about the semaphore. So what actually semaphore? So most of the people think like it will come into in the inter-process communication. It is an this one is a this IPC mechanism, inter-process communication. But semaphore is not like that. Semaphore is like it's a synchronization technique. It allows the processes to synchronize their action. So the important usage of the semaphore is used to synchronize access to a block of shared memory in order to prevent one process from accessing the shared memory at the same time when another processing updating it. What it means, so like if there are two processes, they are communicating with each other. So like we have started the first process. So other process has to wait. So it will try to make that process free, so it will come to that another process, so it can start and all. So we'll go further into that, then you can understand like how in semaphore that block of shared memory are synchronized with each other. And the semaphore is nothing but it's just like a kernel maintaining integer whose value is restricted to being greater than or equal to 0. What is like 0 means there are various operations on that semaphore. So we need to take care of that, like what will be the value of the semaphore. So as you can see here that like there are two processes. So one process is initialize the semaphore to 0, okay, and other is subtract 1 from the semaphore. So now process A will start, and we are adding 1 to that semaphore. So at the same time, you can see like we have run two processes. The other one you can see here, it's like the blue color, some color, and this one is a block. At this time this process B will be blocked, and this will wait no, for the completion of the first process, which is nothing but a process A. After that, after the completion of the process, it will subtract one from the semaphore, and it will go to that another process, and it will add one to the semaphore, and it will continue to run the process B, and at that meanwhile, this first process will block at that time. So when the second process completes the process and all, and it will go further. So whatever, like how the requirement, what will be the requirement of your program and all, so you can manage, you can shift to the third process, or you can you want to go out from that loop and all. So both process have done their work, so you can come out from that program, and that your process will come out and into that shell and all. Okay, so what we will do, we will go to the terminal to see like what are the different calls we are using to make that semaphore. So I'll just go to the terminal. So as you can see, there are three, mainly three calls we are using, three functions we are using, which involved in the semaphore. First is semget. So it will basically create as well as open the set of semaphore. So as you can see here, I'm going to that semget man page. So the semget system call returns the system view semaphore set in identifier sorted with the argument key. So the first argument will be the key. The second argument will be the number of semaphore, and the number of semaphore will be must, like it will be must to be greater than 0, and third is the sem flag. So if you want to use some flags and all, so you can use that. Yeah, so another function is, as you can see here, is semctl. So basically semctl is useful for setting as well as getting the semaphore value. One process can set the value of that semaphore, and another can get the same value if you want to do that. So first you need to create the semaphore, and based on that key, which is nothing but a first parameter of your semget. So you can get the value, whatever the value you have set it in, by using that semctl call. So we'll go into that. So okay, so let's try some code into that. So I just want to explain you regarding the semctl before going to write the proper code of semaphore, so you can have the better understanding why I'm writing that code. So we'll go to Linux system programming. We have completed that IPC mechanism. So I'll just create the directory semaphore. Yeah, we'll go into that semctl underscore set dot c. Okay, so now what I want here is, so I'll just go to the IPC folder, and I will copy the header file to my Semaphore directory. Yeah. Oops. Yeah. So we'll include the header file here. And this program is for setting the value of that semaphore. So first we'll create the function int main, and we'll pass through the command line argument. So I'm writing here, I'm passing the arguments into the main function, argv, I'll create some key id, returning, it will return semctl, it will return the value. Okay, some error message, argc note equals to 3, because first we need to pass the id and the value. Printf usage, we will pass it as a set number val. Return id equals to semget. I'm just creating a semaphore. My first will be the key, number of semaphore must be greater than 0, semaphore 5. Okay, I'm writing 5. IPC create, this is the flag. So if you want to use, you can use, otherwise you can make it as 0. I'm using this flag. Okay, value equals to semctl, my id, my to function, arg p of 1. I'll pass it the number, set the value a to I of arg v of 2. Great. Yep. So now we'll write, okay, so I'll just compile this first. semctl underscore set dot c hyphen o set. Oops. Yep. So now here we will write a get function getting the sem value dot c. Yep. Hash include whatever I can do, I can copy sem set to sem get. Yep, this is easy. I've just changed the number, so I just need to pass the number, so it will return me the value. I can just change here to get, and I can print the value too. So I can just write here, I can write the ID here, so if you want you can write it here. I have already set it in my earlier previous program, so I'm just writing here get value. Yep, great. Yep, so both executables are there. So first I will set by passing the number as 2 and the value is 8. Done. So now I will get the value. So by passing the number 2 here, and I'm getting the value here as 8. So what I've set it. Okay. So in this way you can use the semctl. So now we have understood most of the things, how we can create the semaphore and the semctl, how we can use, how we can set the value and all. So now we will go deep dive into that semaphore. So in this the third function which we are using is semop. So semop is useful for deciding the process has to enter into the critical section of code or not. Okay, so what we'll do, as you can see, like we are adding one on the semaphore, we are subtracting one on the one from the semaphore. So these operations are done by the semop. So it will perform one or more operations on the semaphore. Semop can do that thing. So as we can go to that man page of the semop. Yeah. So first will be your sem id, and second will be your sem buff, like your ops structure, and third will be your size of that array. So that structure, as you can see here, there are the three parameters. So first will be your semaphore numbers, second will be your semaphore operations, and third will be your operation flags. So this operations structure is a pointer to an array that contains the operations to be performed. So as you can see here, so I just want to mention a few things. So if semop is a positive integer, so the operation adds the value to the semaphore. As you can see, I've shown you in a presentation. So initialize the semaphore to 0, and after that add 1 to the semaphore and all. So in this operation is done by the semop. So if the semop is a positive integer, the operation adds the value to the semaphore value, and the other process waiting to decrease the semaphore value. If semop is 0, then the value of the semaphore is just like it'll check to see whether it is currently equal to 0. If it does, then the operation completes immediately. Otherwise the semop blocks until the semaphore value becomes to 0. Means like if it's 0, then it'll go, but if it's not, then it is in that wait state to become it's 0. This as you can see here also, so the process must read operation on the semaphore set. So this is a wait for 0 operations kind of thing, and if semop is less than 0, sorry, then the operation completes immediately. Otherwise the semop blocks until it reaches value to do that operations. So the process must have alter permission the semaphore set. So if sem value is greater than or equal to the absolute value of the semop, so the operation can proceed immediately. So actually semop is individually for every process, and the sem value is common for all the processes. So when they are dealing with the particular resource or whatever. Okay. Yeah. So these are the three calls we have to use in a semaphore, and for more information you can go to this man page and understand, like more understanding of the semaphore, what it is, like how we can use the flags and all. So you can use that. And now we'll go to the semaphore. Will write sem underscore, okay, semaphore p1 process1 dot c. Yeah, so we'll include the header file. Yep, main function, our ID for creating the semaphore for okay. So what I want to do here, so I will just create an array, and I'll just initialize with some string and all, and I'll just try to open a file and all, and we'll do some operations into that. So what we'll do, we will just try to put data into that file or something like that. So we'll use the write calls and all, and for that I just need a file descriptor. Yep, so I'll declare the ft. Yep, and character array, some A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. Yeah, some string struct. We are creating the buffer sembuff, as we can use in semop. Yeah, semop call. Now we will create the ID semget 3 some 5 IPC create. We can just mention the some error message here. Semget. Now we'll just open the file, some data file. O underscore. We'll just write some flags. O underscore append. O underscore create 10644. Yep. So now we'll just write the sem number to 1 and the sem op to 0, as we have discussed, and we are not using some flags, and also we are keeping that flag value to 0. Yeah, so we can write here before executing the semaphore. Yep, so now here we can use the semop. First will be your ID and the buffer structure variable, and I'm passing here 1. Yeah, the number of operations is 1. Okay, so now next what we can do, we can call the semctl, our ID, passing the number as 1. We are setting the value as 1. Printf after the executing the semaphore. So now what we will do, we will just write data into some file and all. Okay, Okay, for so I need to create some like a variable for that, integer I. Yep, I equals to 0, a of I plus plus, right fd address of a of I 1. Yep. We can use some sleep here. Yeah. Printf done. Yeah. So now the operation is done. So we can make the value set value as 0. id 1 set the value to 0. That's it. Escape shift V. So this is a program. So what we will do, this is the first one process. So what I will do, I will just create another process. So I'll just move the semaphore function to some another process. I'll create another process here. Yep. So here I will change this into the capitals, so we can differentiate E F G H I J K L 1 2 3 4 5 6 7 8 9 some values M N O P. Okay, yep, it's great. So we will just execute semaphore underscore p1 dot c hyphen o sem underscore p1. One sec. Did I do something wrong? Oh, I've just moved that. Sorry. I have to copy that. So I'll do some operations back to that. Yeah. Yep. p1.c. Yep. So I'll just change this into the small letters A B C D E F some value. Yep. CC. Yep. Oh god. One sec. I did something wrong here. So as you can see, our both executable is created. So what I will do, I will create, like I'll just open another terminal. Yep. Just then you have the better understanding. Yep. Great. Yeah. So I'm executing first process. Yep. Another process. Okay. Sorry. I'll just go to that directory. So now you can see here my first process is running. So now it is executing. After that, the second process is running. So now what we will do, we will just execute these process together. Like first we will run the first process, and after that second. So now we have the executable. So what we will do here, so we will run here the first semaphore, and in this we will just write the second semaphore. So when the first semaphore will complete, it will print done, then it will go to the second semaphore, as you can see here. So the second semaphore is running, so we are just writing some string into that file. Okay, it's done. So now we can see the data. So okay, so the data is there. So now in this manner you can synchronize with this semaphore and all these things. So later on we can use mutex, minlog. So there'll be so many things we can see here. So if you like this video, if you like this code and all these things, so we will try more in semaphores, like when we will go to Linux kernel programming and all. And in the next session I'll try to cover mutex here, so you can have the difference between. So there are two types of semaphore. One is normal semaphore, which we have discussed in this video, and the other semaphore is the mutex semaphore. The difference is that in a normal semaphore, the process which has locked the key, another process has the authority to unlock it. So means like our first process is running, so other process is trying to unlock the key, and it will go to the second process and it will start executing the process. But in mutex semaphore, the process which is locked the key, only that process has the authority to unlock it. Means if the particular mutex we have declared and we are locking into that some process and all, so after the completion, so only that mutex only will unlock this the locking of the mutex and all. So that will come under the mutex semaphore. So we'll go deep dive into that. So till that, if you like this video, please don't forget to like, share and subscribe, and please do mention in the comments and all if you have some issue, and if you want some another topic, I will explain you, and I'll give you more and more information. Thank you so much.